Good morning, everyone. Today we are going to see about Kartagener syndrome, cystic fibrosis. Along with it, I will be giving you a little bit detail about the transport systems. So before we go delve into the topic, I would like to inform you that there are timestamps and you can refer to the particular topic which you are interested in right now. So the cellular transport mechanisms, there are three important mechanisms. One is simple diffusion. Simple diffusion, as the name says, so if this is the cell membrane and if the concentration of the molecules outside the cell is high and inside is less, then there is a simple diffusion which happens from outside to inside. So in this way the cellular transport happens in simple diffusion. Say for the common example is a nitric oxide which enters the cell. Facilitated diffusion is exactly similar to the simple diffusion. They will freely move down the concentration gradient, but there will be a transport system and they do not require any energy. So this is what is facilitated diffusion, where they will be moving down the concentration gradient with the help of a transport system. So in both the simple diffusion as well as in facilitated diffusion, there will be no energy that is required. So the most common example for facilitated diffusion is blood transporters for glucose, where the energy is not required, but for the glucose to enter into the cell, we need a transporter. And similarly for amino acids, which are larger particles or those particles which are polar, which cannot enter by simple diffusion, it requires a carrier molecule, and that transport is a facilitated diffusion. The third one is the active transport. Active transport, as the name says, this is where an energy or a ATP is required to process this active transport. Active transport is the one where the energy is required. In primary active transport, ATP, here which I have denoted it as a phosphate, directly moves the molecules. Say for example the sodium potassium ATPase pump, where it transports the sodium and the potassium ions across the membranes with the help of the phosphate molecules. So this is how, with the help of an energy, the sodium is pumped out. And in a secondary active transport, here it does require energy in the form of ATP, but not similar to the primary active transport. In secondary active transport, the very best example is the one which happens in the renal cortical collecting duct. Here it is driven by sodium potassium ATPase gradient. I will explain it in detail. So imagine this is the cortical tubule, and this is the apical membrane which is facing the urine, and this is the basolateral membrane. In the basolateral membrane, we have a sodium potassium ATPase pump which will act with ATP with the energy, thereby removing the sodium from inside to outside. In that way, they will maintain an environment where the sodium is deficient or there is less sodium compared to the one on the other side of the apical membrane, that is on the urine side. So in the urine side there is lot of sodium compared to the one which is present here. So the epithelial sodium channel now will act here, and through this the sodium enters into it, even though ATP is not required here, but to maintain a low concentration of sodium over here, the sodium potassium ATPase pump is what is necessary. So this is what is a secondary active transport, where we require a phosphate or ATP to this to function. Let's see about Kartagener syndrome. In Kartagener syndrome, there are three important things, but important components to Kartagener syndrome. But one has to remember that there is impaired ciliary function. Because of impaired ciliary function, the healthy lung is supposed to remove all the fluid or everything out of the lung. But in bronchitis, Kartagener syndrome, the ciliary function is impaired, and therefore it will result in bronchitis. Because of an impaired ciliary function, if the cilia is functioning normally, then from the fallopian tube the ovum will be sent into the uterus. But because of the impaired ciliary function, there is chances of ectopic pregnancy, that is the ovum stays in the fallopian tube and it will result in ectopic pregnancy. It will also result in a reduced sperm motility. In association with this impaired ciliary function features, there is also another feature, that is a dextrocardia, where usually the point of maximum impulse, that is apical impulse, is seen on the right side because of dextrocardia. So how will the question be asked in these cases? The USMLE will give you examples like a 35-year-old female who has recurrent bronchitis and sinusitis throughout life, and there is history of ectopic pregnancy with the cardiac examination shows point of maximum impulse at the fourth intercostal space, right mid-clavicular line. Plus, so with all this, it is very evident that they are talking about a Kartagener syndrome. Now, the biopsy of the nasal polyp is taken. Question asked, which structure is most likely to be absent on electron microscopy of the biopsy specimen? Now, this is what we know. We know that the cilia is impaired, but what exactly is absent in the cilia? That is a knowledge that they are testing. So the answer is the dynanabs, and of course the condition is ciliary dyskinesia. I will tell you in detail about the dynanabs. So this is the cilia. So the cilia is especially made of 9x2 circumferential microtubule pattern on cross section. So in this microtubule pattern there will be dynanabs over here. So in this ciliary dysmotility, the dynanabs are absent in affected individuals. This is almost similar to cystic fibrosis, but the only issue is that in cystic fibrosis there will be absent sperm at all because of the absent vas difference in cystic fibrosis. But whereas here there will be immotile sperm. What about cystic fibrosis pathophysiology? Cystic fibrosis is a problem where there is CFTR gene mutation on chromosome number 7 and it is autosomal recessive. So because of this genetic mutation, there is a defective channel. What is this channel? This is the chloride channel. It is a cyclic AMP mediated ATP gated chloride channel. This is cyclic AMP mediated ATP gated chloride channel. So this defective channel is retained within the rough endoplasmic reticulum. It is not present inside the cell. It is just retained within the rough endoplasmic reticulum. Because of this defective channel, the chloride is not able to be pumped out regularly. Therefore, it will result in growth failure, meconium ileus, as well as respiratory issues. So here we should know that a sweat chloride test is the most accurate test, even more than genotyping. This is because in sweat chloride test, because of this chloride abnormality, it will demonstrate more than 60 milliequivalents per liter of chloride. So we are supposed to check the chloride in the sweat, and if it demonstrates more than 60 milliequivalents per liter, then that is even more accurate than genotyping. This is because of allelic heterogeneity, which means there are many diseased alleles which can produce a cystic fibrosis phenotype. So even though we check the genetic makeup of the individual, we cannot conclusively arrive to a diagnosis whether the individual is really suffering from cystic fibrosis or not. This is because of that allelic heterogeneity. So even more than that, the sweat chloride is a most diagnostic test. The most common mutation among the allelic heterogeneity, the most common mutation is the delta F 508, that is deletion of phenylalanine at position 508. And the diagnostic test is a sweat chloride test, where we will be finding the chloride to be more than 60 milliequivalents per liter. And nasal transepithelial potential difference is also positive. There are few more facts that one should know, like what is the most common cause of pneumonia in cystic fibrosis patient. In the first decade of life, Staph aureus is the most common cause, but in the second decade of life, Pseudomonas is the most common cause. What is the treatment options for cystic fibrosis? Dornase alpha, ALFA. This is a nucleotidase that helps to clear the mucus from the respiratory tree. N-acetylcysteine. This has SH groups that can help break down the mucus. Then guaifenesin. It will soften the mucus. Ivacaftor is a cystic fibrosis CFTR modulator that can help refold the protein into a functional form. These four are the important treatment options in cystic fibrosis. Cystic fibrosis is an autosomal recessive condition. So in genetic counseling in questions, sometimes they might ask, what is the chance of the unaffected sibling being a carrier? So how will the question be asked? There is the patient has come and they have a child, not necessarily patient, a mother and a father has come and they have a child. The child is not affected from cystic fibrosis. Fine. So we don't know whether the child is really normal genotype. Phenotypically he is normal. So he can have either a normal genotype or he can have a carrier genotype. Now the question will be, what is the chance of that unaffected sibling who looks unaffected being a carrier? How do you come to this 2 by 3, the conclusion? This is because we should know that cystic fibrosis is an autosomal recessive condition. So to come to this question, to arrive at this part of the question, it is very clear that the parents must be carriers of cystic fibrosis. So A is the affected gene and the capital A is the normal gene. So they are carriers. So therefore AA and AA, so they look phenotypically normal. So to develop this disease, a person must inherit two defective or mutated alleles. That is the AA, one from each parent. Fine. So the chance that the will be affected is 1. 25% chances that the child will be affected. But now we are not bothered about this. We are only bothered about the rest of the 3. So these 3, they look phenotypically normal. They are normal. They are carriers but still normal. They are also carriers but still normal. Out of the 3, there are two out of this 3, the 2 can be carriers. So henceforth 2 out of 3 of the unaffected sibling being a carrier is the possibility. Thank you for listening all this while. I am happy that you have come to the end of the slide. I hope this is helpful to you. If you have any questions, you can write to me. I am more than happy to clear all your doubts. I have an announcement for you. I am starting my mentoring lessons for medical graduates and USMLE aspirants. If you like my videos and if you like the way I teach, you can sign up for my mentoring class. I can't wait to see you succeed. Thank you. Have a good day.